Just outside of Los Angeles sits a massive mound of buried garbage known as the Puente Hills Landfill. The first load of trash arrived there in 1957. After that, truck after truck continued delivering waste for decades. For over 50 years, if someone in Los Angeles County threw something away, there's a strong chance it ended up somewhere inside this enormous pile. At its busiest, the landfill handled roughly 4 million tons of garbage each year, making it one of the largest disposal sites in the United States. Operations finally stopped in 2013. What remains is essentially a historical record of everyday life, a massive archive of what people bought, used, and discarded over a period of 56 years. But this landfill doesn't only document consumer habits, it also tells the story of how landfill design evolved over time. In 1976, halfway through the landfill's operational life, sweeping federal rules dramatically changed how solid waste had to be managed in the United States. Most people rarely think about what happens after they toss something in the trash. In fact, that's partly the goal of the waste management industry, allowing people to dispose of unwanted items without causing major harm to public health or the environment. Of course, there's an ongoing discussion about how much waste society produces and how much of it could be reused or recycled. But even with better recycling systems, some materials simply don't have enough value to justify keeping them around. Waste, to some degree, is unavoidable in modern life. And when you start looking closely, dealing with that waste becomes far more complex than it first appears. Back in the 1950s, when Puente Hills first opened, a landfill was basically just what it sounds like, a place where trash was dumped into the ground. By the time it shut down, decades later, landfills had become highly engineered systems designed to safely contain enormous quantities of waste. There are many different types of waste produced around the world, but a huge portion comes from ordinary household garbage. Engineers refer to this as municipal solid waste, since local governments typically manage its collection. Once that waste is gathered, there are several ways to deal with it. However, the most common approach by far is burying it in a landfill. And one of the most important parts of landfill engineering happens long before any trash arrives: deciding where to build the landfill in the first place. The goal is fairly straightforward in theory. Engineers want a site that can hold the largest possible volume of waste while keeping construction costs and environmental risks as low as possible. Finding such a site often becomes a surprisingly complicated geometry and planning challenge. At first glance, digging a big hole might seem like the obvious solution, but there's a problem with that idea. Excavation costs money, while leaving the ground untouched costs nothing. Removing huge quantities of soil requires heavy equipment, labor, and time. Then there's the additional expense of transporting that excavated soil somewhere else, since the goal is to use as much of the site's capacity as possible for waste. There are also natural limitations to consider. Engineers must avoid groundwater, unsuitable rock layers, and other geological conditions that could cause problems. Working deep below the surface introduces its own construction and operational challenges as well. So while landfills might seem simple from the outside, designing one properly involves a surprising amount of engineering.